Today we have just started electromagnetism. In electromagnetism, first of all, we're going to learn current through a wire. What happens here? All right. So what happens is that when you have, let's suppose this plane, and there's a wire that is carrying current like that. So to find the magnetic field, you guys need to understand that I'm just going to write here when current moves in a wire, it creates a magnetic field. Alright, kids? Now, to know the direction of magnetic field, we use a method that is called right hand grip rule method. Is it clear, everyone? Right hand grip rule method. Now, this right hand grip rule has some rules. So it should look like your thumb is here and your fingers are like that. Okay, kids? So the thumb shows you the direction of current, and the fingers basically curl in direction of magnetic field. So like this one, if you place your thumb right now, so you can please do it with me so you guys can learn. And your fingers like that. So you might realize that your fingers basically curl in this direction, which is anti-clockwise like that. So there you will have a magnetic field in circles around this. Now these circles are concentric circles. So these concentric circles, concentric means each circle is bigger than previous one with a common center. Now usually at least 3 circles must be drawn. So if you look at the same, plane on a top view, so the current when it is coming out, you would make a dot and a circle. That means the current is coming out. And then you can create you can put the thumb out of the page, and then you can create the circles. Each circle will be bigger than before. Oh my God, why are you drawing on my notes? Each circle bigger than before. And it's like that. All right. Concentric, you have to draw this. So I just want to tell you, just remember when I draw this sign, it means it means out of page. And when I draw this sign, it means into the page. Is that clear? Any questions, please? Yes, Halar, Afraz, Shawez. Do you guys understand? Muhammad's, both of you. Good. Aisha, Rema, Abdullah, Hassan. If you guys have any questions, do let me know.
Sir,
Okay.
sir,
Yes.
can you give like more examples of the right hand rule?
More examples of what?
Of the right
Right.
hand rule. Yeah.
Yes, yes, you're going to do more. I just want to teach you one. You can do, can you like do it, or have you done it right now? Could
Sorry?
have you done the same? Have you tried this? Did you get the same result? Or no?
Sir, so like I keep my thumb like straight and then I try to go in the direction of the current.
Uh,
Or can you
yes,
repeat that again?
thumb on the direction current. See where your fingers are curling into the palm. Can you do that? So you will
Yeah,
see that your fingers curl back into your palm in anti-clockwise direction, isn't it?
indeed. Yes.
Like that. Okay. Please draw this so I can go to the next, please. Now, when you've done this, then we can then look at another example. Suppose this time we're playing like this, but this time the current is going like that into the page. So if I make the top view for it, it basically means it is going into the page like that. This is from the top view. Okay. So if you place your thumb down now, in the direction of current, you'd notice that your fingers are now curling on the other direction. Can you check, please?
Yes.
Okay. So this means that now the field would be like this. Okay, this is not good. Like that, in clockwise direction. So you can also draw it in 2D. At least three concentric circles.
Sir, I have a question.
Yes,
How do you know when to place your thumb downwards or upwards?
it's from the arrow of the current. It's going down, that's why. We know where our thumb should be.
Oh, so we need to know where the current flow to.
Yes,
So what if we don't know where the current is flowing? Which direction?
then they will give you the direction of field. They're going to give you one thing, either the field or the current.
Oh, okay.
Yep. Okay, kids. Okay, draw this, please. Then you're going to go forward.
Sir, could you just tell me when we can find out when the magnetic direction will be going into the page and when it will be going out of the page?
When, how do we know it is going to into the page or out of the page?
Yes, sir.
If they have shown you a cross, it means it's going into the page. And if they've shown you a dot like this, it means it's going out of the page. Understood?
No, sir. So we will. So we ourselves will we ever have to tell whether it'll be going out of the page or into the page?
You don't have to tell it, they will tell you.
Okay. Okay.
So either they can give you the magnetic field, like suppose if they've given you the magnetic field. Oh my god. They're giving you this magnetic field, right? Clockwise. So then they might ask you what is this. So obviously it can be clockwise when it is going into the page. So you can do it with the right hand grip rule. Understood?
Yes, sir.
No? If the field is given to you like this, okay? Like that, and like that. Can't you tell where the magnetic field, where the current is going? Curl your fingers in the direction of this.
Yeah. Yes, sir. The current would be going down, right?
It will be going right into the page, like that. You can only
Oh,
turn your hand like fingers when in clockwise direction when the thumb is pointing into the page. You cannot do it otherwise. You can
so
check.
sir. So whenever our thumb is facing down, it's going into the page.
Yes, like
Oh,
literally into the page. The way you have drawn this, you can put your thumb on it on the page, and then you see your fingers will curl that way. Get
yeah,
it?
yeah, yeah. Okay, sir. Okay, sir.
Into the page means the page you're using. You draw a magnetic field. So thumb towards the page means into the page. Thumb out of the page or coming out would be out of page like that. Get it?
Yes, sir.
Now electromagnetism, and then going to the next. Now that we've learned how field is drawn, we can now go to the force on a current carrying conductor. Now the forces start to act when you bring in two wires together. So in the first part, we're going to learn about two wires like this. That are basically taking current, one out of the page, one into the page. Is it clear? In 2D, it would look like this. If you're looking from top, one is out of the page, the other one is into the page. Is it clear?
Sorry, can you repeat once again?
The current, there are two wires now on the same page. One is taking current up, one is taking current down, right?
Yes.
If you're viewing from the top, this is your eye viewing it. So it means that this current is going into the page and that is coming, sorry, this current is coming out of the page, that is going in. Get it? Like that.
Okay, yes, got it.
Just now, we have learned a couple of things already. We basically learned that when the current is going out of the page, we can use the grip rule. And we'll see that the magnetic field here will be anti-clockwise. Can you guys please confirm? Can you check if the magnetic field is going this way? All right, kids. Now for the other wire, you can check. You can put your thumb down, curl your fingers. You'll see that your fingers curl in this direction. Okay, kids? So now in 2D, it would go like this. All right, do you get it? If you notice at the center, field of the orange one goes like that, and field of the purple one goes like this, right? These fields are basically just the similar fields. If they're similar, they are gonna repel each other. So, same goes here. If you look at the center, fields are going like that. This one is going like that. And because the field is similar, so light field repel, so these two will basically feel a force of repulsion onto them. They will repel. So from this we can learn that current carrying wires in opposite direction repel each other as they create like magnetic fields between them, and like fields always repel. Is it clear? Any questions, please? Have a look at it. Abdullah, do you understand? Rida, Hassan, Fatima, Rema? Very good. Very, very good.
Sir, I have a question.
Yes.
Sir, if these purple lines, right, for example, so if they would be facing downwards, would that mean that they would attract with the orange lines?
If they were in opposite directions, yes, they would
Oh,
attract because they will be opposite directions, opposite fields attract, right?
right. Okay.
We'll do that case as well, don't worry. All right, should I go forward now, please? Now let's do the force. Force on two wires carrying opposite direction current. Sorry, same direction. So one wire going like that, and the other wire also going like that. Both now are carrying current in the same direction. So if you draw the field of the first one, it will be like grip rule. It will be anti-clockwise, like that. And the other one will also be anti-clockwise. You can check. Oh, I made clockwise. My bad. Now, if you check the center, it will be like that. This, this will be like that, and that. So if you see, they are sort of creating a magnetic field in the opposite direction at the center. So now these will attract. Okay. In a 2D figure, as you guys can see, both currents are coming out. So we're going to put out this top view. So the green one looks like this, and that anti-clockwise. And the other one, blue one, is also anti-clockwise. So it also looks like this. If you notice at the center, the arrows from green are going up, the arrows from blue are going down. So they would attract. So we can learn from this example that current carrying wires in same direction attract as they create opposite fields at the center. And you guys know opposite fields attract. Is it clear, kids? Try to copy this and let me know if you have a question. Remember, you need to make the right hand grip rule for that. Otherwise, you won't be able to catch them. Hmm. All right, kids. Okay. Now, done. Very good. Very good. Very good. So, now that you guys have learned it, we're gonna now learn the magnetic field in solenoid. Now for solenoid, like you guys already know, what you gotta do is that suppose wire is coiled up like that, and it is connected with a positive terminal here and negative terminal here. And we want to know how the magnetic field and what direction it is created in. So the first step is that draw the direction of current. So the direction of current will be, it will go back, come forward, and then go back and come forward. So it will be like that. Is it clear, kids? Anybody has an issue with how the direction of the current is? It will go from positive to negative. goes like that. It the rule for different things. So now your thumb is going to show you north and thing. Oh, yeah. Please. Interesting. Second, please. Okay, so I was saying, is it okay now? Hello? Do you hear me clearly? So basically, I was saying, thumb basically
No, sir.
tells you about
But
north.
can you repeat again what you were saying?
Fluctuation.
Sir, can you repeat what you were saying?
Yeah, I was saying the thumb goes towards the north, and oh, my internet is very bad right now. Wait just a second. I know. Yes, I can see. I'm trying to. It was okay, but then I know there's some issue going on. That's why. Trouble. Is it okay now? You kids? Better or not? Yeah, I have to actually restart it and then it will be fine. But for now, just remember that fingers curl show the direction of um, current in a solenoid. Okay. So thumb shows you north, fingers curl show the direction of current. So that means that if you place your thumb like that right now, and your fingers will then curl, your right hand by the way, your fingers will curl like this. These are your nails. So you see that your fingers are in the same direction as the current drawn, isn't it? Which means the north is going to be created here and south will be created here. And the field will now go from north to south like that.
Sir, could you just please explain why the thumb would be facing towards the right side right now? Again?
Because if you see your fingers, put your right hand like that. Can you see your fingers pointing towards the direction of current, which is
Yes, sir.
here?
They're facing downwards. Yes,
And then where is your thumb?
it's facing towards the right side.
Right side, so that would be the north then. This is how you're gonna check where the field is going to be.
Okay.
Understood?
Right. Okay.
So this is how they're two different, like the same rules for two different things. One for solenoid, one for single wire. You can take it out so you guys can learn. All right, kids, everything's clear. So this would be then all for today. Inshallah, on Sunday, then we're gonna look at this in more depth, and we'll try to finish this off and